Yeah, and then very last technical topic for you is GANs, so generative adversarial networks. We talked about them really early on in the episode. A few years ago, they were the way for generating things. And so I suspect, I haven't read your first edition, but I suspect your first edition was really heavy on GANs.
Yeah, definitely. Yeah, it's I sort of see GANs as in many ways the trailblazer, because a lot of the techniques and the way in which we approach generative AI was founded through the GAN movement. And there was like a GAN a week at one point. And it was kind of a running joke that, which GAN are we going to be seeing this week to do some niche thing? And I hear people now saying GANs are dead, and I don't know why you've included them in the second edition, and it should just all be about diffusion models and transformers, and that's it. And first of all, the GAN discriminator is still used in so many really powerful models. The concept of a discriminator constantly operating over the top of whatever you're using as the generator to distinguish real from fake, and using that in the loss function, is something that's still very much alive today. Take a model like a model called VQ GAN, so vector quantized GAN, and variations of this. Is still one of the most powerful image generation models out there. It's not the case that diffusion models are ruling the world just yet, and that and StyleGAN XL, for example, is still incredibly powerful and is dominating a lot of the leaderboards. So, look, I never like to chase the latest thing and say that this is it and we've all innovation has stopped. But I hope what people can sort of take from the book and also take into their own learning is that it's good to have a general understanding of what's come before, because you never know what's going to come next and where it might come back into fashion. They're a super interesting idea that I think is going to be around a long while.
And in addition, you have a bit in your book about combining GANs with transformers.
Yes. Basically, what I would say to anyone looking to get into generative AI is look for the crossover between these fields, because whilst we bucket them up in the book into, now we're doing the GAN chapter, now we're doing the transformer chapter. What I would say in general is a lot of the powerful models out there are actually, they've got components of all of them. So like you mentioned there is a type of model in the book that effectively has a transformer within it in order to do part of the encoding of a piece of text. But there is a GAN discriminator in there as well. And when you're looking at a lot of these multimodal models, they've got diffusion in there, they've got GANs in there, they've got transformers in there. So they're using the right tool for the job. They're not like just saying, well, I'm going to use one model type and that's all I'm going to use in the model, because a transformer is brilliant at modeling sequences. A GAN is brilliant at determining fake from real. Diffusion models are fantastic at working with very rich latent spaces that you can sample from. And the best models out there use all of these techniques. And I think they will do in the future as well.